Hello, students. My name is Trish, and I'm an engineer. You might be wondering, what's an engineer? Well, an engineer uses science, technology, and math to solve problems. We invent, design, analyze, build, and test things like bridges, machines, or different types of materials. You can see engineering in the whole world around you. Things like bridges, bicycles, medicines, even the toys you play with. What I'm going to talk about today is how we can use engineering to help clean up the environment. So how do you become an engineer? Well, when I was in grade school, I really liked math and science, and I liked playing with toys like building blocks, and I liked taking toys apart and putting them back together. So when I went to college, I studied chemical engineering, and I decided that I wanted to use that to help clean up the environment. So that's what I'm going to talk to you about today. In my job, we work outdoors in nature to clean up the soil and groundwater from chemicals. If a chemical is dumped to the bay or to a river or the groundwater, our job is to figure out how to safely remove the chemical from the water to clean it up. But in order to figure that out, we need to understand the different properties of water and the chemical so that we know how to separate the two. So depending on the chemical, it might like to dissolve in the water or it might stay separate. So today we're going to talk a little bit about how chemicals behave in water and how we use that information to clean up our environment. So we're going to learn about two properties today: solubility and surface tension. First, we'll talk about solubility. Okay, first we're going to talk about solubility. Solubility is measuring the amount of chemical that can dissolve in water at a certain temperature. Can you think of something that dissolves in water really well? I can think of orange juice or Kool-Aid or sugar. So we're going to do a little experiment showing how something dissolves in water. So what I have here is just a cup of water, just plain water. And I'm going to take some pink food coloring and add it, and we'll see what happens. So here comes the food coloring, a couple drops, and I'm going to give it a quick stir with a spoon. And look at that, it turns very nice and red pink. So imagine that the red that we added was a bad chemical and we didn't want it in the water. We wanted to remove it. Do you think it would be hard or easy to remove that red food coloring from the water? Well, it's all dissolved in there, so I think it would be pretty hard, don't you? So we might have to do something like send it through a filter. So let's try that. What I have here is a camping filter, and I'm going to separate it and show you the filter part. So this part, it's a little wet. This part is a filter, and what we're going to do is put this red food coloring and filter it. So I'm going to pour it in here, just some of it, and then I'm going to put the filter in there, and I'm going to have to push it down really hard. So I'm going to push it down and try to filter this water through that filter. It's going to take a second because it has to be pushed through really hard. And as I push it through the filter, okay, now I've pushed it through the filter. I'm going to pour it into a different glass. This one's empty. And let's see if it changed. Yeah, it cleaned up a little bit, didn't it? It's not quite as pink as before. So we might need to send it through the filter a few more times to make it really clean. But that did a pretty good job of cleaning that water. Now, can you think of something that doesn't dissolve in water very well? Things like cooking oil, motor oil, or even a plastic toy. If you put that in the water, it probably is not going to dissolve, right? So let's try our experiment again, but this time I'm going to add cooking oil. I'm going to use this same red water because it's really easy to see, right? So I have some cooking oil here, right here, just plain old cooking oil. Let's see what happens when we pour it into the water. Pour it in. Look at that. Do you see that there's 2 layers there? I'm even going to try to stir it up like I did with the red food coloring. Try to stir it up and see what happens. Yeah, that oil just stays separate, doesn't it? The oil is called hydrophobic because it doesn't dissolve in water. Now, do you think it would be easy or hard to clean this water and remove the oil? Well, it might be a little easier to remove most of it because we could maybe just, pour it off, or we could have something like a vacuum to suck that off because it's just floating on top, right? But after we do that, there's still probably a little bit of oil that's dissolved in the water. And then you might need to send it through a filter like we did before to really make sure that it's clean. So by knowing how the chemicals react with the water, we have a good idea of how to make that water clean again and remove the chemicals. Okay, so we're going to do one more experiment, and this one shows solubility like we've been talking about, but we're also going to talk about surface tension. Water molecules have a very high attraction to each other. They like to stick together, and that's called having a high surface tension. That's why water forms droplets when you see dew on the grass in the morning, or when it rains and there's droplets of water on something that's metal or plastic. All those little water molecules are huddling together. So to do this next experiment, I'm going to move my camera and show you just the experiment. For this experiment, I have a regular paper plate, and I'm going to put some water in it to start with. So I'm going to pour some water in here. And now I'm going to put some black pepper in this water. Do you think that the pepper is going to dissolve in the water? Let's see. Nope, it doesn't dissolve, does it? All those little pepper flakes are just hanging out individually. That's because the pepper is hydrophobic. Do you remember that word from earlier? Now, what else do you notice about the pepper flakes? You might not be able to tell, but I can see that most of them are floating on top of the water. And that's because the water has high surface tension. Think about the water molecules all holding hands really tightly and not letting the pepper move through the water. How do you think that we could change the surface tension of the water to make the pepper move? Well, I have here a little bit of just plain soap. This is just plain hand soap. And I'm going to put some with my finger right in the middle of this plate of pepper. Look at that. The soap breaks the surface tension of the water, and as the water molecules stop holding hands and move away from each other, they take the pepper with them. So how do you think that we could use this property of surface tension to clean the water? Well, it's a lot easier to clean up all this pepper at the edge of the pie plate rather than it was when it was spread all over, right? So by changing the surface tension, we've concentrated the pepper and made it easier to remove. Well, that's all I have for today. I hope you like learning about solubility and surface tension, and thank you so much for having me in your classroom. Remember that by understanding how chemicals work together, we can use that knowledge to help clean up our environment. Thanks, everyone. Bye.